Okay, it's 8 o'clock now, so we're gonna start. I got feedback from my mom to share my screen with the homework questions while we talk about them. So I'm going to do that. Okay. So
I was really busy last week, so I couldn't come to the classes, and I didn't have time to do the homework, but I did some of the homework, like half of it. Is that okay? I'm really sorry.
it's okay. You're fine. I'm gonna actually, if you guys can see my screen right now, I'm sharing the homework problems. And again, Amy, it's fine if you didn't make it last time. But let me, okay. So these are the homework questions from last week. Does someone want to begin talking about them? Sharon?
Can I answer it?
Can you what?
Can I answer?
Yes.
Okay. So, all right. Hey, I need that. I can't annotate either.
Oh, yeah, yes. Let me add annotation for you guys. There.
Okay, all right. Basically, I just duplicate your graph there. So, group of one, like why is the sign? There's 5 of those. Just count 1, 2, 3, 4, 5. A, B, C, D, E. Groups of 2, there are 0. And groups of 3, there are 5. And just 5 plus 5 is 10. So the answer is 10.
You want to draw out what groups of 1 or 3 triangles you found?
Groups of 3 triangles?
Groups of 1 and 3 triangles.
Okay, then it's just gonna fill up, but
No, just like one example.
Okay, sure. How about this?
Yes. That is an example of a triangle that's made up of 3 triangles. Okay. Cool. I'm going to clear your annotations. We can talk about this next one. Very similar strategy. So I'm gonna go ahead and actually talk about this one. But oh, actually, okay, William, do you want to talk about it?
I got 30.
Unfortunately not. There's 5 more. Do you want to talk about it?
So what I did was there are 10 single triangles in this picture. Is that right?
Mm-hmm.
And there are 10 triangles that are made of 2 small triangles: A, J, G, F, J, I, F, E, I, H, D, C, H, G, B, C, D, E, and A, B.
Yes. So there are triangles like the small one, and then there's triangles like this big one.
Okay. And for triangles that have that are made of 3 single triangles, small triangles, there are 10. But I'm not sure if I'm correct because you said there were 5 more.
Yes.
What about 5 by 5?
Hold on. So the 3 that William was talking about are something like this.
Yeah.
This is what's in 3 triangles. And yes, the last one that Xiao just showed out, there's one, for example, here.
Oh.
And that's triangles made up of 5.
Oh.
Yeah.
And
And
are there 5 of those?
mhm.
Oh, I see. Because there's a pentagon here. Yeah, and you can do
Yeah.
Oh, okay. So thanks for pointing out my mistake.
And if you add them, that's 35. Okay. Next question. Let's see. Does someone want to talk about this? William, is your hand still up?
Yeah.
Okay. Do you want to talk about it?
So there are 9 single triangles. There are 3 triangles that are made up of 3 triangles, and
Three?
there's one triangle has the entire one, which is 13 total triangles.
Okay. Yeah, so there's one like this, and then I think William misspoke here, but there's one like this, and that's made of 4 triangles.
Yeah.
And there are,
Yeah, 4 triangles.
and there are 3 of those, one here, and one here. And then there's one more, this big triangle that has everything.
Yeah.
Okay. Okay, Shara, do you want to talk about this question?
Okay. It's pretty obvious. Just split in half. That was awkward.
Yeah.
1, 2. Yay. Fun fact, there's a pattern.
Wait. 1, 2, what do you mean by 1, 2?
So,
It's not 1, 2. That's the amount of pieces there are,
Yeah,
but it
that's what I
asks for
meant.
how many intersections there are.
Yes, exactly.
I'm just saying that there's 2 parts.
Okay, then how many intersections?
Wait a second.
There
I
are
thought
no
it was from
intersections.
parts. I thought it was the number of parts.
Can I answer?
Yes, William.
Okay.
There is
I'm
also
just gonna answer to C, all right? I'm just gonna answer to C, all right?
Sure.
So for A, there are 0 intersections. For B, there are 2 intersections.
2?
Wait, one intersection.
Yes.
1 intersection. And for C, you have 6 sections.
Let's talk about how you got that.
Oh, so I just use the formula, the same for the handshake thing Andrew shared last time. N times n minus 1 divided by 2 will make us, will give us all the answers. Because if you draw lines, you can see these intersections. Like handshakes is basically where they meet. One intersection is basically one handshake. We can say it like that. And so for C, you get 6 sections. Because 4 times 3 divided by 2 is 6.
Yes, this is the way that remember our pattern from last time. There's another pattern here. And that's why we can use that. But also remember that when we're thinking about intersections to find the greatest number, what we want to do is we want to have one of the lines intersect all the previous lines. So our third line here, we want to intersect both the 2 lines we have here. And then for our 4th line, we want to intersect all 4 of the other lines. And that just creates, for that last one, 2 more. And then for this next one, 3 more. And that leads us to this next question here. Since we know that 4 has 6, when we think about 5, we want to intersect all 4 of these lines we have here. That just means 6 plus 4 or 10. 10 seconds here.
Wait, why?
Remember when you were talking about the largest number of intersections? We wanted to intersect all of the previous lines.
Yeah,
So,
but where did you get 6?
oh, from here.
Oh, I see.
Yeah.
Okay.
Yeah, that was the pattern that I saw. Oh, add 1 plus 2 plus 3 plus 4.
Okay, and there's 2 more down here. We had what was it, 10 for 5? And for 6, we wanted to intersect all 5 previous lines, so that it's in plus 5 intersections, so 15. And then for this last one, we want to get 7 first. So we add 6 intersections for 7. And then for 8, we finally add 7 more intersections onto that. Okay. Any questions about this? Okay, cool. Moving on to today's material then. We are going to be talking about, wait, hold on. Okay. We are going to be talking about perimeter and area of squares and rectangles. Okay. First, we're going to be talking about perimeter. This is a what'd you say?
It's so like specific. Perimeter and area of squares and rectangles.
Well, if you think about it, perimeter and area are like similar concepts.
Perimeter and area is really only simple if it's like a square or rectangle.
Perimeter and area is not exactly specific, I guess. Area is just times and perimeter is just addition, so.
Yeah,
Except
they're really
when it comes to triangles.
They're basically the same because multiplication is basically the same as addition, so.
William, do you have a question or a comment?
No, I just have a fun fact.
Mm-hmm.
So for perimeter and area are 2 things, but a 4x4 like a square with side length 4 has a perimeter equal to its area.
Well, yeah.
Yes, and I think one of our examples actually talked about that, but just very briefly because we're on this topic, and you guys seem to know this topic, so we're going to be talking about it relatively quickly. The perimeter is just, I'm going to call it P, it's a bad P, but P. It's just the side lengths of whatever this is all added together. So in this case, it would be length plus width, and then once more on these 2 sides, length plus width equals to 2 length plus 2 width. So an example of this actually be, let's do this one first. Oh wait, no, not triangle.
Oh, I know how to do these.
How?
No. Of a rectangle.
No typo.
What is the perimeter of a rectangle with lengths 5 and width 11? 10 seconds to do this.
Done.
Done.
Okay, I'm not sure who, actually I think, oh no. William, I think you raised your hand first, so do you want to talk about it?
He was keeping his hand up the whole time.
So You can do 2 times 5 equals 10 plus 2 times 11 equals 22, which gives us 32. But also you can do 5 plus 11, which is 16, and the 16 times 2 equals 32.
Yeah, that's what I
Yep.
did.
Just to rephrase that from our equation here, we can rewrite this as 2 times length plus width. Okay, now that we have practiced with that, let's talk about this one. Remember that the definition of a perimeter we have is just all the length of all the sides added together. So think about this question and think about what the perimeter of this is. 20 seconds.
Done as well.
Okay. Shell, your hand was up. You want to talk about this?
It's 12. Quick math. All right. So let me show you the process. It's just counting. 1,
Yes.
Or
2, 3 times 4 is 12.
oh my
Gavin, trying to say something?
what you could have done was you could have yes, you could have multiplied 3 by 4 because if you added the corner squares, there would be no difference.
Yeah. Okay. So Gavin's point was what was something I wanted to bring up. If you're to rewrite, I guess make this so that these side lengths are not there anymore. Pretend these side lengths are gone. Then you would see that it's basically the same thing. So we would be doing what Shao did, just a square with side length 3. So then the perimeter would be 4 times 3 or 12. Okay. Moving on. What is the perimeter of a square with side length 4? William was talking about this before, so I'm not going to spend time talking about it, but essentially you have a square and the side length 4. Since you know that all side lengths are the same length, you can just do 4 times 4.
That looks more like a rectangle.
Okay, Gavin. There, it's not a rectangle anymore.
That's a rectangle.
No, the side lengths are labeled as 4. So it's not a rectangle.
But that's
Okay.
illegal.
No. Okay.
Nice.
What? Was someone talking? Okay, never mind then. What is the length and width of a rectangle with perimeter 30 and length twice the width? I'm going to give you guys a minute to try and solve this.
Done. Should I send it in the private chat?
Hmm?
Should I send it in the private chat to you?
Sure.
Okay.
That's not private chatting. You just sent it to everyone.
Remember to find the length and width. Yeah. Okay, a minute has passed. Who wants to talk about this question? William, you can talk about it.
Oh. Yeah.
Go ahead.
So, so I did 30 divided by 2. That gives us the sum of the width and length. And you see that 15 is 5 plus 10, which means the length is 10 and the width is 5. But to make that more clearer, you can see that there are 3 lengths is 15. You know, like 1 width plus 2 width which is what length is equal to 15. So that means you basically you just multiply with times 3 to get 15. And to solve this, you just do 15 divided by 3 equals 5. Width equals 5 and length equals 5 times 2 equals 10.
Yeah, that is one way you can approach this. Another way you can approach this is to think algebraically. So when it says the length is twice the width, you can write it as L, or length, is equal to 2 times the width. And since we know that the formula for perimeter is this, you can set that to 30. And you can also set length equal to 2 width. So this results in 2 width plus width is equal to 30. And then we can divide both sides by 2 and add this parentheses here. So 15, and then that just means width is equal to 5. And then to find length, we multiply this by 2 because of this equation here. So we just have length is equal to 10. Okay. Any questions about this? Okay. Here's another similar question. I'm also going to give you guys a minute to try and solve this. Okay, so a minute has passed. William, is your hand up to talk about this?
Yeah.
Okay.
So the length is 35 and the width is 7.
Do you want to tell us how you got that?
So if you want to see wait a second. Wait, what? Oh, I think I got it wrong.
Okay.
I see. For 32 divided by 2 equals 21. That's the length plus width. And 21 divided by 6, well, can't do that.
Yeah, you can.
Yeah,
You can.
it results as decimal.
Mm-hmm.
So
I'm just gonna solve that really quickly. So
Okay.
21 divided by 6. Oh.
Yeah. While William is talking about that, we can write out what is shown here.
Yeah. 3.5. Yeah, 3.5 is the width.
Mm-hmm. Okay. So first, we can look at the width being 1/5 of a length. So that just means W is equal to 1/5 of the length. And then we can multiply both sides by 5. And then that just results in 5 width is equal to length. This is kind of unnecessary. You don't really have to do this, but I like doing this because fractions are kind of annoying to work with, especially later on. Okay, so we know that, again, this equation here, we can substitute 42 for the perimeter. We can write length as 5 times the width. So we have 2 times 5 width plus W is equal to 42. We add whatever inside this parentheses, so 6W, and then we can divide both sides by 2, 21. So that just means width is equal to 21 over 6. To simplify this, we can divide both numerator and denominator by 3. So that results in 7 over 2. And then writing this as a decimal to preference, you don't really have to do this, but you just get 3.5. To get the length, we need to use this equation here. So 5 times the width, or 7.5, 3.5. And multiplying that, we get 17.5. Any questions? Okay, moving on. How many rectangles have a perimeter of 10? To do this, you basically think of the number of combinations of length and width you can have that have perimeters of 10 without repeating. And think of this, we're not going to be talking about decimals, so only whole numbers. Only length and width that have a whole number of units. Okay, I'm going to give you guys a minute to try and solve this.
Does that include the same variables but different length and width?
No. Wait. Same variable?
For example, the length is 2, and for the length is 2 and the width is 3. Does the length is 3 and the width is 2 count?
No.
Okay.
But a minute is up and I see people raising their hands. William, your hand went first, but Andrew hasn't talked to you, so do you want, is it okay if I call Andrew?
Okay. A parameter is like, can I annotate?
Mm-hmm.
A parameter, this is n, this is n, this is m, this is m. So 2n plus 2m equals 10. You divide both sides by 2, you get n plus m equals 5. And n can be 1, m can be 4, n can be 2, and n can be 3. So the answer is 2.
Yep. I'm going to talk about this in variables that we were using before. But remember when we were talking that the formula for perimeter is 2 times the length and the width. We can substitute for 10. Again, like Andrew said, dividing both sides by 2, that results in 5. And remember that we only have whole number side lengths. So these are the 2 combinations that we have without repetition. So 2. William, is that what you also got?
Yeah.
Okay. Does anyone have any questions about this? Okay. Moving on then to area. First, area is like what Amy said before, essentially what perimeter is, but instead of adding, you multiply. So the area for something is the length times the width. Okay. So just for practice, what is the area of a rectangle with sides 9, 2? No, I'm not going to be accepting answers on this. We just talked about it. But essentially what you would do is area is equal to 9 times 2. So the area is 18. And what is the area of a square with sides 3? Remember that in the square, the length is equal to the width. So the area would then be 3 times 3, or 9. Yes, William.
So another fun fact.
Okay.
For squares, you basically just square the side length, because that's why it's called square. You know, like something times itself.
Yeah, like squares are all sides the same, and you basically have to do like the area of the square, which is like pretend the square is like 6 on all sides and you want to find the area or something, you can just do 6 times 6, which is 36, and that's a square too. So
Yeah.
Well, only square area variables are square numbers.
Yeah. I'm just saying, like, if you want to find the area of a square, you can also use the side length.
basically squares are just two of the same numbers adding together, or you can have, so it's basically saying you can have like s to the power of 2, which is a number to the power of 2 is a square. So you can put any number in s.
Yes, the point that you guys have all made is correct, and that is a good way to think about it. Any more comments or questions? Okay. This we're going to be talking more about area here. Surface area here, it just means area, so you can ignore the surface. But the surface of a swimming pool is rectangular in a shape that measures 12 meters by 20 meters. A concrete path 2 meters wide is constructed around the surface of the pool. What will be the surface area of the path? Just to give you guys a visualization. So we first have a swimming pool. This is a swimming pool. Here, those are waves. And this is 12 by 20. And then you have a pathway around it that is 2 meters wide. So, like this. And it's asking you for the area of the path. So, this shaded area. Okay. I'm gonna give you guys a minute to try and solve this. Okay, so the minute is up. Does someone have a start to a solution about this problem? William, is your hand up for this?
Yeah, yeah.
Okay.
I'm not sure if I'm right, but you first want to see the area of the entire part that the concrete path is um is like go like envelops around, like, so it kind of like you just have to do 22 plus 2 times 12 plus 2, which is 22 times 14. That is 308. And the swimming pool has an area of 20 times 12, which is 240. And then the difference, you just have to find difference, which is 68. Is that right?
Very close, but you're missing actually something. Does someone have an idea of what William missed? Just to recap, William was saying the length is 20 plus 2, and the width is 12 plus 2.
Oh, I think I see what I missed.
Okay, do you want to talk about it?
I saw that, yeah, I cannot see that it has the swimming pool is less than the length and width of the swimming pool is 4 less than the length and width of the concrete path.
Right. So actually, for the length here,
Yeah, on both sides is 2 less. So actually you'll just have to do 4. Like,
yes.
yeah.
Since the path goes all the way around the swimming pool, you have to add 2 times of how wide that is. So for this big area, we have 24 times 16. And then to find the area of the blue region, you just minus what's the area of the swimming pool. So that's just 20 times 12. And if we were to solve for that, 24 times 16 is 384. And then you minus 20 times 12, so 240. And that's 144. Okay, there's one last thing I'm missing. Does someone have an idea of what we're missing? Okay, it's the fact that we have to have units. So it said here that it's 20 meters by 20 meters. When you multiply something, you also multiply the units. So when we have a meters times meters, this just results in a meters squared. And since we did that and we're solving with area, we have 144 meters squared. Now I want to emphasize a difference here. If first off, if there were to be no units, the default units is units or u, so this would be u squared. But also, if we were to go back to, for example, our perimeter question, let's go back to an easier example. Here we have as 4 units plus 4 units. When we add 2 units, the units doesn't change, it just stays as what was previously there. So the units here would be u and not u squared. Okay. Any questions about this? Okay. Moving on. Find the area of the floor plan. So it's essentially asking you to find the area of this gray shaded area. And I'm going to give you guys a minute to try and solve this. Okay. How many is up? Does anyone want to talk about this? I'm sure that you guys have different ways that you approach this, so we can listen to both of you talk. But William, since you're handing out first, you want to first talk about it?
Okay, so wait, can I annotate?
Sure.
Okay. So basically, you can split it into 3 rectangles. One is like this. My drawing is bad, but yeah, like this. There's a rectangle there. How do I move that menu?
Okay, wait. William, to help you out here, I can. Oops, that's not what I meant to do. Here, I can just annotate it on my side, and then
Okay.
you don't have to worry about that.
So for on the bottom, like 3 meters all the way to the like that part. Yeah, so there are 3 rectangles here, and 3 rectangles, and so for the bottom, it's wait. Oh, yeah. It's 30 times something. Wait a second. How can I wait.
It's
Yeah.
can I,
Gary, you can help me.
it's 30 times 5
Oh, okay.
because on rectangle A, the right side, it says 15 meters and the total.
Oh, yeah. I remember. Yeah. Okay. So for the upper part, the A rectangle, you get you have to find 7 meters times 50 meters. Is that right? Yeah. And I didn't solve that. Oh yeah. It's 105. Okay, so for the final one, C, it's 10 meters times 7 meters. No, it's a 7 because the length of of rectangle B is 5, and then 12 minus 5 equals 7.
Yes.
So at last, you just add all these together. Equals that equals 3. Oh yeah, 325.
Yes. Oh, hold on. I have lots of chat messages. Okay. Well, anyway, it's all about this question. This is the one way you can solve this question. Let me talk through another way, and we should get the same answer as what we had here. So in addition to the rectangles that William drew here, we can also do something like this. And just the same A, B, and C. A here, it would be 20 times 7. As you can see by the side length, it's 140. For B, we know that the height is 5, so we can write that down. But then this middle part here, it'll be this 30 minus 7 minus 10. So that would be 13. So it's in 65. And then for this last part, we can multiply 10 by 12, because those are the side lengths. That's 120. Now, if you were to add all of these, we also get, we should also get 325, and it seems like we do. Okay, So for overall, for questions like these, there are multiple ways to solve for them. Any way would work. Just make sure to get your multiplication right and divide it in a way that's reasonable. Does anyone have any questions about this? Okay. That is all the material for today. We are going to be doing College Ball now. Paula?
Kahoot.
Yeah, I want to do Kahoot.
We have lots of
Kahoot.
Kahoot.
Sorry, not today. We have lots of time. And
What about Hangman?
Oh, Hangman?
okay, let's do Math is Cool. Let's do College Ball for 10 minutes and do Hangman for the last.
The math is cool.
Yeah. Let's do College Ball first, and then we can
5th grade.
do Kahoot. Okay, I'm getting confused on which ones we have done and which one we haven't. Okay. Oh, okay. This is okay. Question number. Actually, before I start, just a reminder: if you have your answer, raise your hand, or physically, actually, or virtually, and anything is fine. And then I'll call on you, and you will give your answer. If you get the answer right, you can help explain to the class how you got it right. But if you got the answer wrong, I'm going to call on someone else if someone else has their hands up. Okay, question number 1. What is the product of 32 and 16? Question number 1. What is the product of 32 and 16? Oh, Andrew?
Let me see. 512.
Yeah, okay. This is a pretty simple question, so I'm not going to ask Andrew to explain it. I hope that everyone also got 512. So question number 2. What is the length of one side of a regular hexagon with a perimeter of 24? What is the length of one side of a regular hexagon with a perimeter of 24? Andrew?
3.
No. William?
4.
Yes. Gavin, did you also get that?
Yeah.
Okay. Remember that a hexagon has a side length of 6?
I forgot.
So, yeah, it's fine. But when you're talking about perimeter of 24, you just divide 24 by 6 and you get the length of one side. Okay. Number 3, evaluate 1/2 A plus 2B if A is equal to 4 and B is equal to 1. Evaluate 1/2 times A plus 2B if A is equal to 4 and B is equal to 1. Andrew?
6. 2 plus 4.
No.
Wait, 1 over 2A
William?
plus 2B.
Yeah. William?
Is it 4?
Here, let me share screen about this one. So what we're asking
I
to
think
do
I
is,
know the answer.
huh?
Wait, is the answer? Wait. What's A? What's A?
A is 4, and B is 1. So we're asking to do 1/2 A plus 2B. So 1/2 times A or 4 plus 2B or 2 times 1, and that is equal to 4. Okay. Fourth question. How many prime numbers are between 10 and 20? How many prime numbers are there between 10 and 20? William?
4.
Do you want to listen up?
Yes.
Yes, you want to listen up?
Wait, what?
Okay,
List them out. 11, 13, 17, 19.
Yeah, okay. Sorry, William, I was asking if you wanted to list out the prime numbers. I don't think you heard me clearly.
Oh, I thought if I wanted to do more.
Oh, okay.
Oh, okay. So, yeah, like Andrew said, it's 11, 13, 17, and 19.
Okay. Okay, this one, I haven't talked about this in class yet, but Alex, Bob, Cassie, and Dimitri are seated in 4 chairs in a row. How many different ways can they be seated? For a certain Alex, Bob, Cassie, and Dimitri are seated in 4 chairs in a row. How many different ways can they be seated? Andrew?
4 times 3 over 2, 6.
Sorry, no.
Raising my hand.
Oh, sorry, so.
You literally raised their hands at the same time. Is it 4 factorial 24?
Yeah, okay.
Wait.
Do I want to tell us?
Total chairs. How many total chairs?
4.
You said there are 4 chairs in a row.
Mm-hmm.
How many rows?
A row. 1 row.
Oh, then
Yeah.
there's only one way. 1 times 4.
Then
People that are sitting in the chairs.
24 ways.
The way to arrange them somehow.
Yeah. Okay. We have 4 people. Their names start with A, B, C, D. So I'm just gonna say A, B, C, D. For this first chair, anyone can sit in it. So there's 4 choices 4 people we can put in this first chair. Okay. And assume we sit like A here. There's 3 other people left. So for the second chair, there are 3 possible ways to seat people in it. There's 3. So pretend we put C here. And then for this third chair, we have 2 people left that can sit here. 2. Pretend we put D in here. And then for this last one, we only have 1.
4 times 3 times 2 times 1, right?
Yeah. So then what you do is you multiply all of them together. So then you get 24.
So you're sitting in the second chair?
Huh?
So you're sitting in the second chair?
I'm sitting in the second chair.
Oh, Mom just be like, hello.
Yes, she's gone now. Okay. Anyways,
Here, you're in the last second chair.
I understand.
Can we do Kahoot now?
Hangman.
I thought we wanted to do Kahoot.
I want to go.
Kahoot.
Let's do
So let's
Kahoot. I
do
want to do
Kahoot.
Kahoot actually.
Kahoot.
No,
Okay.
God,
Okay, let's go.
No,
wait. Okay, wait. Oh my God, wait, who's sharing this? Xiao, no. So
Good at Hangman.
Okay, we're gonna take a vote. How many of you guys want Kahoot and how many of you guys want Hangman? Raise your hand if you want Kahoot. Zach,
Physically?
Gavin. Huh?
Physically or virtually?
I'm not sure how we would do physically. Okay, how many of you guys want to do Hangman then? Everyone else?
Hangman or me?
Well, Wait, no one's voting.
Let's go to
Wait,
Hangman Army.
nobody's voting.
Exactly. Hangman Army always somehow wins.
I voted for Kahoot.
Oh, okay.
Yes, too.
What about Amy and
Yeah.
Olivia?
Olivia, do you want Kahoot or Hangman? No, we couldn't hear you.
Can you hear me now?
Yes, we can hear you.
Okay. I vote Kahoot.
No.
Amy,
Yeah, I have something to show you. Mega
Amy,
Mix.
do you want Kahoot or
What? I will make a mix too.
Is it soft?
do-
It is completely soft.
Amy, do you want Kahoot or Hangman?
All up to her.
Okay, I'll have a Hangman.
Oh, guys.
So it's a tie.
Can I vote?
It's a
I'm just
tie.
going to, okay.
Oh,
I'm going
command.
It's a tie.
Hey,
Yes, it is a tie.
oh,
I
cool.
will-
Wait, can you turn
Hey,
your
let's
back
do
enough?
command.
Guys,
So
guys.
we should do command.
What?
You have
Command.
a 4x4?
Oh, I have a 5x5.
Okay,
What, command?
guys, because we're running out of time, I'm going to make the executive decision to do Hangman.